In this example, we'll have a look at solving trigonometric equations in terms of the ratios of all the applicable sides. So you might ask why I'm saying all the applicable sides. So let's have a look. The example in this case, we have a right-angled triangle. Let's call that ABC. And in this case, we have a line running through here which causes another angle, which we'll call D. Also a right-angled triangle. And of course, what this creates is two extra right-angled triangles within the triangle ABC. So what we're going to have to determine, or the trigonometric equations we have to solve in this case, are the sine of B, the cosine of C, and the tangent of B. Okay, so let's make some sense out of the triangles that we have here. Firstly, we know that we have triangle ABC, which is a large triangle. So let's draw that over here so that we have a point of reference. So that's triangle A, B, and C. Then we have the smaller triangle in the top half, which is triangle ABD. A, B, and D. And then we have the triangle in the lower half, which is ACD. A, C, and D. So this gives us a point of reference so that we don't get confused as to where the triangles are and in determining which angles are applicable and which sides are applicable, because it can get quite confusing pretty quickly. So next, let's just write down our SOHCAHTOA mnemonic so that we can remember our trig function. So it's SOHCAHTOA. Okay, so let's start off by doing the sine of angle B. So let's mark angle B so that we have a reference to that. So first we need to identify which triangles are applicable. So in this case, angle B is within the triangle ABD. So let's write that down. Triangle A, B, and D. And within the larger triangle ABC. A, B, and C. Then next we need to identify the sides of the triangles. So we know that we are dealing with angle B, and then the hypotenuse is always the side opposite the right angle. So in triangle ABD, it's the side AB, and in triangle ABC, it is the side BC. Our opposite side is of course the side opposite the angle in question. So we have that as the side AD and as the side AC. So we know that when we're dealing with sine, we are dealing with the ratio of the opposite side over the hypotenuse. So in effect, that answers our equation for us. We just need to write that down. So in triangle ABD, the opposite side is side AD over the hypotenuse, which is the side AB. So that is the ratio for the sine of angle B within the triangle ABD. Then we have a look at the ratio for the sine of B within the triangle ABC, where we have the opposite side AC over our hypotenuse, which is BC. Okay, let's have a look at the cosine of C. So we'll mark the angle C, and then we'll have a look at the bigger picture and determine which triangles we are dealing with. So in this case, we are having a look at the triangle in the bottom half, ACD. So let's make a note of that. ACD. And we are dealing with the large triangle ABC. A, B, and C. Okay, so the cosine function is the ratio of the adjacent side divided by the hypotenuse. So we're dealing with angle C in this case. So let's identify our sides of the triangles. So as usual, the side opposite the right angle is the hypotenuse. And then we need to have a look and determine which is the adjacent side. So in triangle ACD, it is the side CD. And in the triangle ABC, it is the side AC. So there you have it. Now we just need to write that down. So the adjacent side is the side CD over the hypotenuse, which is the side AC. Or in the case of triangle ABC, we have the adjacent side, which is AC, over our hypotenuse, which is BC. Alright, so let's finish this off with the tangent of B. Okay, so I'll mark B in green. So we know we're dealing with the tangent function. And then we can identify our triangles. So again, as with the sine of the angle B, we know that we are dealing with triangle ABD, A, B, and D, and of course the larger triangle ABC, A, B, and C. Okay, we are dealing with the angle B, so let's mark that off as well, and then let's identify our sides. So we know that with the tangent function, we are dealing with the ratio of the opposite side over the adjacent side. So let's just mark our hypotenuse of both angles, both triangles, so that we don't get confused when determining the opposite and the adjacent sides. So there we have our hypotenuses determined, and then we need to determine the opposite side and the adjacent. So in triangle ABD, our opposite is AD. In triangle ABC, the opposite is AC. And the adjacent would be BD and AB, respectively. Okay, so now we just need to fill that into our equation. So for triangle ABD, the opposite side is AD over our adjacent side, which is BD. And in triangle ABC, our opposite side is AC over our adjacent side, which is AB. So hopefully this makes it a little bit easier. In mathematics, it's often a good step or good practice to take a step back and dissect things to make them slightly easier. So in this case, just to recap, we dissected this larger triangle with the two triangles inside of it so that we could make a little bit more sense and then individually determine what the ratios are of the different sides for each trigonometric equation.